The second half of topic 5 has us looking at function operations and inverse functions. In 5.5, we'll do function operations. We will add, subtract, multiply, and divide, and we'll evaluate composite functions, recognizing when we need to determine the domain. We start off this lesson pretty straightforward with adding and subtracting functions. If you have multiple functions like f of x, g of x, h of x, y equals any sort of equation, what you do when you add and subtract is simply combine like terms. We've done that before. There's nothing tricky with this part. As always, the thing to be mindful of is when you're subtracting functions, we need to make sure we subtract all of that entire second function. All right, let's try a couple of quick examples here. When you define the sum, or how do you define the sum f plus g and the difference f minus g of the functions f of x and g of x? If we have f plus g, we're not literally adding those letters together, we're adding the function outputs together. F of x is equal to 3x plus 4. So we literally just substitute that in place of f of x. G of x is x squared minus 5x plus 2. And when we add, we're just going to combine like terms. Writing in order from biggest term down to constant, we would actually put x squared first. That eliminates that term. The x's, we have 3x minus 5x, and that would equal minus 2x. And last but not least, the constants, 4 plus 2 equals 6. That's literally adding functions together. I think we can handle that today. Again, with subtraction, we want to be careful. As we list out our terms now, f of x, still 3x plus 4. When we subtract g of x, though, we're subtracting that entire quantity. I'm going to put it in parentheses just to make sure we know exactly how to distribute that in. To subtract, we need to make sure we change all the signs for that second function. That gives us 3x plus 4 minus x squared, and then plus 5x minus 2. Now let's combine our like terms. Our lead term this time is negative x squared. For our x's, we have 3x plus 5x, which is positive 8x. Gets rid of those two. And then for our constant, we now have 4 minus 2, which would be plus 2. That's finding the difference of two functions. When asked to multiply functions, you'll either do some sort of distribute or FOIL, and then combine like terms. Let's look at the example on the right. The demand D in units sold for a company's new brand of cell phone at price X in dollars is this equation. D of X equals 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? So if we think about it, revenue is going to equal price times demand. The money that the company takes in is equal to how many cell phones they sell at a given price. So if the price is X and the demand is 5,000 minus, another zero, minus 10x. If we want to figure out the revenue, we're going to multiply the price and demand together. We'll start off R equals for revenue, price, which is X, times demand, which is 5,000 minus 10x. To figure out a simplified form for the revenue, distribute the X in, and that would be 5,000x minus 10x squared. What we could do then is figure out for a given price of the cell phone, what would be the company's revenue. Out of the 4 operations on functions, dividing has the most rules to follow. It's like dividing rational functions back in chapter 4. Yep, we're bringing that back a little bit. When asked to divide, the first thing you want to do is just set up the fraction for the division. So we'll just say set up the fraction. Oops, there we go. I hit a button on the left-hand side and it threw off my process. There we go, we're back. So if we set up the fraction, what's going to end up happening is we're going to follow our rules back from chapter 4. We want to first factor anything that could break down into smaller parts. And we'll do that in case we need to state restrictions. Oh yes, that's back. Anytime we have a fraction with a variable, it's a rational fraction or a rational function, we've got to follow those same steps as before. Once we state our restrictions, our final step would be to reduce if anything on top and bottom is an exact match to cancel out. Our last example for the video, how do you define the quotient f divided by g given the two functions f of x and g of x? So just like before, if we set this up, at least the nice thing here is we're not adding and subtracting or multiplying a bunch of fractions together. We're just taking one fraction and simplifying it. F divided by g means f of x divided by g of x. And that would be x minus 7 over 2x squared minus 13x minus 7. With variables in the denominator, that means we have to figure out if we need to state restrictions, and we will. To factor that denominator, and we have with an a value out in front, we're going to have to do a times c and multiply it with that earmuff method. So a times c split to get b. 2 times negative 7 is negative 14. Trying to figure out factors of negative 14 that add to get that negative 13 in the middle. If we multiply that negative 14 times 1, we would get that to work. So remember, when we do this split method, we have to break down these 3 terms in the denominator to 4. We'll keep our 2x squared. And then in between, we're going to break down that negative 13x into negative 14x plus 1x. And then we put that last term minus 7. Now to factor, we'll break up the 4 terms into 2 parentheses, and then we look for common factors in each set of parentheses. For example, in 2x squared minus 14x, we could take a 2 and an x out of both terms. And if we do that, we get x minus 7 left over. Oh, can you guys hear the birds outside? It's really early in the morning, and my cats are looking out the window listening to the birds, and they're having a field day. So if you guys hear all those noises, sorry, I have to keep them happy. All right, let's finish this problem. In that second parenthesis, we have just x minus 7, but we need a placeholder in front. So make sure to remember, if nothing factors out other than 1, we need a placeholder of 1. And then we have a matching factor. Oops, there we go. When the parentheses are the same, that's one of our factors in our final answer. And then the other parenthesis comes from the parts on the outside. And that's why we need that 1 right there. This will be 2x plus 1. So now f of x divided by g of x is x minus 7 in the numerator over x minus 7, 2x plus 1. Now with this fraction, we're going to have 2 restrictions in our domain. Let's identify that before we simplify. X minus 7 means that x can't equal positive 7. That would make the denominator fraction 0, or of the fraction. 2x plus 1, if we set 2x plus 1 equal to 0, subtract 1, divide by 2, x also can't equal negative 1/2. Those would be our 2 restrictions. And then step 4, last but not least, notice we have a matching factor in the numerator and denominator. The x minus 7 on top can cancel with the x minus 7 on the bottom. Be careful on this part. The 2x plus 1 stays in the denominator. It doesn't get to move up to the top. The numerator is just going to have a 1 as a placeholder. And then we'll have the 2x plus 1 in the denominator. That should be the extent for division. We will finish the rest of our notes on the back side of this lesson tomorrow in class.